Since this is Meet the Members, I'll just say another word about myself. I am, in addition to a lecturer at Columbia, I am Naomi's daughter. If you're wondering about the last names, that's not a coincidence. And I could say a lot about that, but I'm going to just show you an image of what I got my mom for Mother's Day and wonder if any of you could give your mom this t-shirt. So it's been a pretty cool ride, I'd say. Anyway, let me make sure that there's okay, nobody can annotate. So my talk is kind of about Ridgeline Plots, but not really. What I really want to talk about is education and how to teach data visualization, and also hear from you. This is a Meet the Members, so I want to just do a couple quick things on the chat to get to know you a little better. If everyone can just tell me your first name, what you like to be called in the chat. It'll be kind of neat to see that. I know a lot of those are on Zoom anyway, but if you could just put your first name in the chat, I'll start. Yeah, there we go. And oh, cool. Yeah, that was a good idea. We should have said where you're from. Why don't we do that too? I am in New York right now. I assumed, I guess because this is New York, that's where a lot of people are, but it could be probably all over. Fantastic. So now the next question's getting a little bit more technical. What is your go-to language or program or app or whatever for data visualization? And if you can't decide, you can list them all. So curious what people are using. Okay, so we're getting a mixture, a lot of Python, high charts. I am the program. That's a good answer. Yeah, that was when we started working together. I said, well, if you want to work for me, yeah, I guess you could do the coding. I don't like coding. You could do that for me. So that was how the collaboration started. So I'm going to come back to that at the end. And so if you could think about that and think about what you would want to learn in data visualization, if you're in industry, what you wish the people you're working with knew, there's so many, data visualization is so many different things, and there's so many different things you could focus on if you're teaching. So I'm always happy to hear different opinions and different directions in that regard. So let's go back to my screen share. And, one of my principles in teaching is data visualization is to focus on the data, really get people away from the idea that you start with the chart that you want to make, but start with what data do you have, and how do you visualize that type of data. So we start with continuous data. It's not obvious to students at many different levels, what the difference is between categorical or continuous data, and what the difference is between discrete. And discrete, for example, is a really difficult category because sometimes we graph it like continuous data, and sometimes we graph it like categorical data. If you just have 1, 2, 3, 4, 5, you're going to treat that more like categories than if you have 0 through 100, something like that. So really thinking about your data, and then kind of starting with continuous data, what are our means for graphing a distribution? What is a distribution? It's this collections, population of numbers, and our kind of workhorse for that is the histogram, where we bin the data and look at counts. This is also a place where people who use Excel start to see well, maybe there's other things maybe it's worth learning something else, because even something like a histogram, which is just such a basic tool for anyone who does data viz, would find it difficult to do in Excel. And I apologize if I'm not up to the latest in Excel, but from what I've tried, even with the data analysis packages and things, it's really clunky. So we talk a lot about how data visualizations aren't, they're not objective in the sense like you just make a data visualization, you just say, give me a histogram, and then like, this is the data set. I like to use an analogy of a photograph. So this is like a picture of the data set from one angle, and you can zoom in, you can zoom out, you can look at it from different perspectives, and you're going to see something different. So let's just hear from you. What kind of things would you change in a histogram to get a different view? And by the way, I should think about that, but I'll just tell you what you're seeing. TFR is total fertility rate, and that's a measure of how many children a woman has in her lifetime and over her reproductive years. Each value here represents a country. So there's a country that has an average total fertility rate close to 8. And then there's many that have total fertility rates less than 2. It's a complicated calculation that, like every indicator, you want to look into, like, how do you do that when a woman's reproductive years span decades? How do you average that when it's also fluctuating and the numbers are changing? So it's not at all straightforward, but this is what the measure represents. So what do we see in the histogram? We see it looks like there's a lot of values around 2, then it drops off. It looks like it might be increasing a little bit. There might be sort of a second mode somewhere around here. But what kind of things could you change to get another look at this data? Okay, good. Cameron, you want to expand on that?
Sure. Like if you reduce the number of bins, like if there were fewer bins, you wouldn't get as much detail.
Right, exactly. So there's no one right bin width. There's some clearly wrong bin widths. And this is another concept that I focus on a lot, that just because there are multiple right answers, not all answers are right answers. So there's clearly wrong answers, like having one bin for all the data is wrong. Having one bin for every data value is wrong, but there's this kind of a range of sweet spot, and you want to play with that and see what you see. You might see some patterns one way and not other. There is, and this is often very difficult for students, particularly ones with a stronger, like very technical background, don't like it when, like, well, is it bimodal or is it not bimodal? They don't want to hear, well, it looks like it could be if with this bin width. So that's another thing that I try to explain. So let's move forward. Histograms work really well for one distribution. Once you start breaking things down, it gets difficult to compare histograms. So this is an attempt with faceting to break it down by continent and look at the distribution of total fertility rate by continent. So these all have the same scales. That's the default in ggplot2. And so we can start to see how they differ, how Europe has much lower total fertility rates than Africa. There's a lot of distribution. There's a lot of variation, I should say. And another kind of go-to for comparing distributions are box plots. So what do box plots show? What are we looking at? I know we're like familiar with that, with the name, but what actually are we seeing? Like what is the box in a box plot showing? So the box in a box plot shows good, right? Approximately, there's different methods, but the original the original formulation by Tukey shows from the first quartile to the third quartile, which is approximately which can be the 25th to 75th percentile, it's just slightly different methods. Exactly, right? And even within R, base R uses Tukey's method and ggplot2 uses the 25th to 75th percentile, and there's multiple methods for calculating those, but it's basically the middle 50% of the data is shown inside the box. And some people hate box plots, and there's like good reasons to not like them or to want to use other methods as well, because you can't see the modality, you can't see whether it's bimodal or multimodal at all from a box plot, right? You're just looking at kind of the spread of the different quartiles, and then you can see outliers as well. How much time do I have? I didn't pay attention to when we started. You're muted.
As much as you need.
Uh-oh. Okay, no, I won't talk too long, don't worry. So we can compare the box plots and histograms. For outliers, the box plots are better for seeing the overall distribution, seeing if there's different modes. The histograms will be better. They just, it gets a little messy. This could be cleaned up a little bit, but it is a little hard to fit in the facets. You kind of have to change things around and move the labels so that you don't end up with a plot that's 50% labels and 50% data. So moving toward the ridge lines. This was the histogram that we started with. This is a density histogram. So this is an important concept to understand. The density histogram, okay, is useful for comparing distributions that have very different counts. The way that a density, notice that it's exactly the same, right? The only thing that changes is the y-axis. And the way that a density histogram works is that the area of the bars is equal to 1. Because it's showing you the full distribution. So the probability of landing somewhere in the distribution is 100% or 1. So if you have numbers greater than 1 on the x-axis, if those are the values that you have in your data set, the density will be less than 1. Sometimes though, if you have very small numbers, if what you're measuring is just very small, the density can go above 1. Remember, because what's important is that the area is 1. So students sometimes think something's wrong if they end up with a very high density here, but it all works out. So we're moving in again, one step closer toward ridgeline plots by looking at a density curve. And what a density curve is really just a smooth version of a histogram. Okay, and again, the area under the density curve is 1. So just like we're used to looking at normal distributions and the area under the curve, the probability of being somewhere in the distribution is 100%. That's what we're seeing here. So even though a density curve looks like a line chart, it's not a line chart. Okay, line charts can do anything. Line charts can go up, they can go up exponentially. They're representing individual values. They're not representing a distribution. Okay. The other important thing about density curves is that just like histograms, you can change the bin width. You can change you can change the smoothing parameter for a density curve. So you can have density curves that go up and down a lot more, like a sort of similar to a histogram with very narrow bin width, or you can have one that's much smoother. So don't read too much into like the height of the mode, right? What you're looking at for a density curve is really the shape. Is it unimodal? Is it multimodal? Is it skewed? You're not looking, the heights can change so much with very minor changes to the parameters. So you want to be careful there. Another thing you can do with density curve is overlap them. So here I divided it up into I separated the data into North America, I filtered out North America and South America. And then by overlapping them, you can compare them a little bit easier than you would with histograms. And histograms, you really can't overlap. There's just too many lines and it's kind of difficult to see. But again, I'm really just looking at kind of where this mode is. I'm not paying a lot of attention to the height. So now ridgeline plots. Ridgeline plots are just density curves that are drawn to overlap. And what the benefit is that they allow you to put a lot of information in a really small space. And they're also kind of cool. And, you know, we all know that people like cool stuff in data viz. And at first I thought they were inspired by this kind of well-known graph from radio pulsars, which also became an album cover. And there's like a whole subculture around this graph. I actually saw someone with a t-shirt with this image on it just yesterday walking in the park. These are not density curves. These are individual readings to the best of my knowledge. I think it sort of came after, though. It wasn't really the inspiration. It was more like a connection that was made after the fact. So if we go back, let's go back to this one, because this is one I really like. You could not do this with box plots, because remember, box plots don't show you where the modes are. So this is data from the American Time Use Survey. And they ask people, you know, what they do, but they also ask them when they do it. So you can look at different activities, like playing billiards or dancing, and those are activities that people tend to do later in the day. And then you have activities that people do kind of all day long. And then there are other activities that people do both in the morning and in the evening, but not in the middle of the day. So there's really a lot of useful information in a small space, and it's ordered very well in that, like, you from morning peak, the ones at the bottom have earlier. I'm not sure if they did it by median, but probably by median. That's how I would have done it, up to the top. And one thing you'll learn if you from Naomi, that like the most important thing, I don't know, correct me if I'm wrong, but the super important thing in any graph is thinking being very thoughtful about the order of the categories. Okay, and if you just slap down those categories in alphabetical order, you are asking for big trouble, especially if you're coding for Naomi. So ordering things by median is generally a good way to do it with something like this, or with box plots, for example. So there's a package in R that allows you to do this. It's called GG Ridges. And as you can see, it's really just these density curves lined up. You don't have to have them overlap. Depends on how many categories you have. You can change the scale so that there's gaps and each one is separate. You want to think about the order of those categories. I've ordered it from lowest on the left to highest on the right. It might be better to do it the other way around. If you have an opinion on that, you can let me know. Again, I'm not paying, there's no y-axis here. If there's no y-axis, I am not going to read a lot into the height. I'm not going to say, for example, like, well, this is about half of what this is. It's just there's too many things that have been smoothed out in that process to say that that's a meaningful thing, especially when like the scales can be changed and those heights change. You're looking at the shape. So it's just kind of something else to keep in your toolkit for comparing distributions for the same scale, really generally subcategories of the same thing. I'll end with one tweet. And, you know, Twitter is just so fun for data visualization. There's so much stuff going on. And this was one where they're comparing ridge lines to box plots. Any thoughts on which you prefer in this particular comparison and why? So just anything, just which would you do? There's no, no necessarily right answer, but I do have an opinion. I'm gonna go with Sagar with the box plots. I like the box plots too. What do you think? What are you thinking?
So I think the ridgeline in this particular case is giving us an idea of the trend, overall trend line, or like a categorical trend if we separate all the states there. But the box plot not only gives us trend line, but also like gives us an idea of the exact specific peaks and the distributions of the individual quartiles.
Right. I think what made this one so useful was how the shapes of these distributions were so different, and that would have all gotten lost in box plots. But here, the shapes of the distributions are really boring. They're all the same. They're all unimodal, so like seeing them all on top of each other really just doesn't contribute much. The color also, that's another principle that if you're coding for, like, I should write a book, Coding for Naomi. No unnecessary color, right? So like that's just bad, right? To have this unnecessary color here. But that aside, right? This, you can see, you can compare the medians in a way that you couldn't here. So this is providing more information and not losing anything about the shapes of the distributions. So I would do that too. If you're interested in doing this in art, it didn't look like we had a lot of our users, but if you can check out the GG Ridges package, and I'll post the slides. I can post code if people are interested, and I'm happy to answer any questions about anything I've shown, or more just really about education in general. And I'd like to hear your thoughts as well about data visualization education. So that's all. Thank you for listening. And I'm going to stop my screen share so I can see more people.
Questions? Comments?
I was curious about your experience with teaching Ridgelines. Do students get it right away? And if not, what kind of misunderstandings might people have with Ridgelines when they first see them?
Yeah, I mean, I think that there's this problem with, we do density curves first. So once they've done density curves, it's kind of a natural progression. But I wouldn't teach it without really teaching density curves first and really understanding what that's showing and what a distribution is first.
Yeah, I really like that about your presentation, how you walked us through going from the process of something familiar like a histogram and built that. I thought that worked pretty well.
Okay, thank you.
Joyce, I'd like you to put the t-shirt back on the screen.
I'm going to show you, let's see. Oh, I hope I can find it. Let's see.
What this t-shirt shows is the symbols that R uses. If you have, for example, a scatter plot with just one variable, it will use the open circle. Open circles have the advantage that it's easy to see overlap. Then if you have a second point, and this is, okay, so the one is the open circle. Now, in the original S language, before there was an R, the second thing was the plus sign. If you look at the cover of my book, it has an open circle and a plus sign. These symbols were developed from studies on perception and what people saw. And I was very surprised when I got the shirt to see that the second one was the triangle. I thought second should be the plus. And I have been meaning since Mother's Day to look up R symbols and to see when it switched from the original S to what Joyce now says R has. But in any case, these symbols are very carefully chosen to be distinguishable, and they're based on studies of perception. If anybody's interested, I can put references on. I don't have them in my head because I didn't know she was showing this, but I discovered this work from Bill Cleveland's work, and he gives a reference in his book to the studies from which they're taken. So,
Well, I'll just say something else about that, which is that, like, this is really old school in a way, and it looks very like base R graphics, but going back to Ben's talk, a lot of this, like, we've really switched to color instead of symbols in many respects. And if you like, most people's go-to now would be to make let's say a scatter plot with 3 groups, and with 3 different colors instead of 3 different symbols. Symbols look like something from, I don't know, the 70s, right? But for if you're visually impaired, the symbols would work better. And if you need to make photocopies, the black and white, right, the symbols work better. So it's kind of interesting. Like we've advanced in some ways, but we're making things more difficult in other ways.
that's why some people recommend symbols in different colors.
This was another one of my, like, there were so many, I didn't know which one to choose, but this was this was another possibility. I'll show you. I'm giving away my secrets for future occasions, but there's some some really fun ones here. I'm just so curious, like, who is behind these, because there's the Jon Snow cholera scarf, the Napoleon map, neck gaiter. Yeah, I can give you no, that's not true. Here, this one. And finally, so there you have it.
Back to the talk. Are there any questions or comments? As you can see, the apple falls very far from the tree because Joyce is making a name in coding, and that is my weakness. My strength is what you should do and not how you should do it.
She's kind of underselling herself, let me just say, like when, when she has really high standards. Like when I started coding, I said, well, how do I learn what you want me to do? And she just hands me Paul Morell's book on like R graphics, which is like that thick. It was like no like Code Academy or like online tutorials. It's just like, well, read this. And I'm looking through like PAR and all these lots of detail. So she knows what she's doing when it comes to coding.
Comments on the talk? Any comments for any of the speakers? Anything you want to say to Ben or Cigar or Joyce?
Is Joyce going to do something? She did the poll at the beginning.
Yeah, I want to hear. And I mean, I kind of just asked it, but I would love to hear people's thoughts on data, like either speaking or put in the chat what thoughts you have about data visualization education and what's important. Well, it's probably getting to be dinner time or whatever. So, we can pick up this conversation another time. Anyone can always get in touch.
Another question, does anybody have suggestions for future speakers? Again, if you're hiring, please put your contact information in the chat. And if not, I thank you all for coming.